everyone to episode 14 of the Space Shooter livestream series on DevVenture with MTK. So the last time we left off with separating the gun from the player. Alright, so we've got a gun mesh and we've got a marker 3D and a timer shot cooldown, and everything was working. There were some bugs, but we fixed them just before the end. And the last thing we wanted to do before I run out of time, if I go back to scripts, so I've thought about it. Okay, I've remembered what I wanted to do. I wanted to create a single player scene that is built up programmatically at runtime, depending on the player selection and all of that stuff. But I've thought about it, and it's unnecessarily complex. What I mean is, it's possible, it's definitely possible, and I can do it, but the amount of time and investment it would take to do that is not going to be paid back. So the savings in efficiency and what we gain from all that effort isn't worth the effort itself. Now that might sound lazy to some of you, but if you think about it, right, it's only one component, one small little component, a grain of sand in the beach, and there's so much more we need to do. And as you've seen, things can take very, very long if we deliberate over minute details like this. So I'm going to avoid it. I'm going to keep going with the modularization and fundamental principles, right? So there are some best practices that I will not give up on, right? But this one, even though it is a best practice to have one scene called the player, and then it's got this like script that should build up the player exactly as it's supposed to be for it, for every scene as it starts, right? So as a level begins, it should build the player up from the separate pieces. And that is the best setup. But I'm going to forego that for now, and I'm going to keep having a mining vessel scene and a defender ship scene and a pirate ship scene, right? One as the player, one as the NPC, and then that means 6 in total. And potentially even 9, because you want, well, it depends how we program things, right? So if I group things correctly, then we won't need 9, we'll only need 6. So remember, if you choose, if you go to node and I select an appropriate node, you'll see in the defendership scene, I can go to groups, and you'll see now there are global groups and scene groups, right? So what I can do here is I can establish groups. I can say player, NPC, or enemy, right? And then I can, as far as I'm aware, it's possible to set something as a part of a group through script, right? So let's check with DeepSeek if that's possible. So is it possible to adjust a scene's grouping from GD script at runtime? For example, if I want to set a pirate ship .tscn object as player part of the player group when a scene begins, can I do that? Also, if the same pirate ship .tscn object is meant to be an enemy or ally NPC, then I want to choose which group the object belongs to from GD script at runtime. Can we do this? Amazing. So yes, you can. So you can say add to group and remove from group, and you can even check if is in group, which is the default use case for groups, right? If this thing belongs to a group, so if it is in group name, then in the body of that if statement, do this thing, right? So if the object that the plasma bolt has collided from is in the group mining object, then don't take damage from the plasma bolt. However, if it is in group target, then do take damage, right? So the same thing, we can add it to a group and remove it from a group at runtime, which is perfect. That means that I could, but I don't want to, I could have just a single script for each of the scenes, so the player scene, the mining ship scene, the pirate scene, and then have these conditional bodies in every function, right? So if it is of player, then have player logic, but if it is of enemy or ally, then do NPC logic or something, right? But I would rather have separate scenes, right? So a player pirate and an enemy pirate, a player ship and an enemy ship, a player mining vessel and an enemy mining vessel, and then have in the, or rather player and NPC, right? Because otherwise we would have three groups: player, enemy, ally, which means we'd have to have three scenes for each of the classes, right? And that makes 9 in total. So like I told you, there's this trade-off, okay? So let's just illustrate that in Krita for you. So if I go there, I can apply this. Perfect. So let's create a new image. Perfect. So you've got this trade-off, right? Let's say here is space, and here is time, and here is complexity. Okay? And you've got this like balance that you have to strike between them. So you can, if you were to do like a so-called spider plot, right, that would be like this. And then you have a color that is different, so like orangey colors like that. Then you have to choose, right? Do I max out on space and ignore time and complexity? Or do I max out on time? Or do I max out on complexity? Or do I choose up to 2 of the 3 and forego 1, right? Because you can't have all of them. Now, what does this mean, right? What does space mean? What does time mean? What does complexity mean? So space means on your hard drive, right? I have a hard drive. Let me draw it with a rectangle instead. So I've got a hard drive, and then I can minimize the amount of space. So let's say this is the space that's already taken up on this. Let me just do another rectangle. So this one, something like that. And then I can fill this with red. Okay. Okay. So now if I do this, I can say that this here is existing disk space used. So this is the existing space that's used up on my potential player's machine. Okay. How much space on their hard drive do I want to occupy at most, right? So if they've got, this much space left, am I going to take up all of the remaining space or as little space as I could possibly do, right? Ideally, you want to be as small as possible, right? So you want your program to be the smallest possible size you could ever make it. And so you want to be brutally optimal with how you take up space on your player's machine, because again, you think of it as being not rude, right? So considerate, because the opposite of considerate is inconsiderate and rude, right? So you don't want to be rude and occupy more than you need. Don't be wasteful with your player's machine space. So let's say this is the optimal size, right? You can't make your program smaller than this. But in reality, it ends up being like this instead. So let's just draw something like that. And then just color this in rather than fill it. Okay, and now if we do a key, we can say this, and then we've got white with stripes, and then we've got a red block like this. That's a solid color. Okay, and then we do another color for description. So this is expected space. This is actual space. And this is existing occupied space. So this is other taken space. Right, so this was the expectation, and this was the reality. Okay, so in reality, you're never going to get as ideal as you can imagine. So if you want to take a trade-off on one of the other two, you can optimize on space, right? So you make things as tiny as possible. And how do you do space savings? Well, you can do things like you save, let's say you have 10 variables. You need 10 variables, right? To operate your stuff, your player or your whatever. But 8 of those 10 variables can be derived, calculated from 2 of the other 2, right? So you could use the other 2 to derive the remaining 8. Then to save on space, you would derive them. You would derive them at runtime. You would say, okay, well, variable 3 is equal to variable 1 plus variable 2, for example. And then variable 4 is variable 3 divided by variable 2 raised to the power of variable 1, whatever, right? Some calculation. The problem with this is that you've saved all the possible space you could, but you have sacrificed both time and complexity to do it, right? Because you're taking up time, runtime, and frame rates to calculate that variable, right? And when I say calculate the variable, I mean calculate it. I don't mean declare a variable and then calculate it once at the start of the scene. I mean every single time you need that variable, you calculate it again from scratch each time, right? Because if you saved it in a variable, you're taking up space, right? That's the whole point. You want to evade taking up unnecessary space at the cost of computation time and complexity, because now you're calculating every single time, and some of those calculations are non-trivial. Like I said, for example, you'd be raising something to a power or calculating the square root or doing some crazy calculations, right? So that's the space saving at the cost of the other two, right? So if you want to maximize your space saving, you have 0 savings on the other two. So let me just show you. What is this? This is size, right? No, there's size. Okay, so that's way too massive. So something like this instead. Yeah. Okay. Now if we zoom in, a space saving would look like this on your spider plot, and then have nothing else for the other two. Okay, then you've got a time saving. So what does a time saving even mean? So let's change this to 3 and then calculate this, or show you this. So time saving is calculation or computation time. Okay, so anything and everything that you do in a game costs time, potentially, anyway. So if you've got 60 frames a second, so again, let's do that box, some kind of box, okay? And the full box represents your maximum computations or calculations or whatever complexity, not complexity, but the amount of bandwidth or memory or RAM or whatever resources your computer has available to it, right? Before it starts losing frames. Okay, so when this meter overflows, we drop from 60 frames a second. So let's say that. So 60. Switch to pin. Yeah, so 60 frames per second, and less if the box overflows. Okay, so ideally we want to use as little of this resource box as possible, right? So we want to have some kind of so again, we've got some default resources being used up by the operating system and Godot engine and some other things that might be taking up those resources, and we can't control this. Then we've got the expected consumption, right? So we expect ideally, in the ideal case, the minimum time resources that we want to use is like this much. Okay? But then the reality is like this instead. So something like that. And then we use that same key, right? So red is existing consumed resources, orange is expectation, and this like translucent white is the reality. So to achieve the orange box, we would need to be brutal with our time resource use, right? So in order to do that, we would need to make some serious sacrifices with space and complexity, right? And so time and complexity are very closely linked. The more complex, no, they're not actually, sorry. I remember my definition for complexity was how complex development is for me rather than how complex the game is for you as the player on your machine, right? So they aren't that close. So I want to make things as complex as possible and take up as much space as I can to save time, because apparently time is more important than the other two in this example, right? So we want this thing to be running as efficiently as possible. Let's say the game I'm making is a competitive game, right? Then every single frame per second counts, and you really, really don't want to upset your players, especially the really competitive ones, because they are extremely critical of frame rate consumption and stuff, right? So you want to make sure that it is at least 60 frames per second or as high as you can possibly get it above that, right? Because if you drop below 60 frames per second, they are gonna throw a tantrum in this example, okay? And to do this, you want to take up as much possible space as you can on the machine, right? You want to save variable and a duplicate variable and a derived variable and everything as much as you can, right? So you don't have to do any calculations, or you do as few calculations as possible, right? You literally only do the calculations that you cannot avoid. And complexity wise, you make it that for your development, you make things as modular as possible. You make things link together, and you connect things up with signals, and you do all kinds of convoluted design patterns and things to make things absolutely and optimally time efficient. And then you'll have your time maximized, right? And so then that would look something like this. it would look something like that. Something like that. Okay, so that's a time saving. Okay, now what on earth is complexity? So let's do that one. And then we can get back to Godot engine. Okay? Right, so complexity wise, we'll do that same box. Okay, so this is the optimal complexity. And we'll just denote this with green. We'll say complexity one second. Okay, complexity before development suffers. And then what do I mean by that? So we say IE takes longer, and error fixes are harder. Okay. So now we go back to a block, we change the color to red, we do the expectation, or the default taken up, right? So default complexity is like this. Because we decided to make a game, it's automatically complex in some ways, right? So we can't avoid that. That's the automatic complexity. Now we go to the expected complexity. We don't expect the game to be more complex than this to make. All right? But in reality, this is what we see. We see something kind of like that. Okay? With all of our efforts to reduce complexity and to be as simplistic as possible, in reality, we are slightly more complex than we would like to be. Right? So that's the reality. Now, how do we make sure that our complexity is as little as possible? Right? The simplest way is throw away time and space. We don't care, right? We make duplicate scenes. We do unnecessary computations, and we don't bother making things efficient. We simplify things. We don't go the additional steps to tidy things up or make things elegant or any of that stuff. We don't care, right? We don't care how much space the game takes up. We don't care how much computation time we save. We just make the development process as easy as we can possibly make it so that we can actually finish the game and we can actually ship it out on time. We can actually make some money from it, right? So this is a developer-centric parameter, whereas the other two are player-centric parameters. So they concern the player more than the developer, whereas complexity concerns the developer more than the player. And so we become completely selfish. We don't care about the player. We just care about our quality of life in the development cycle, right? So we make things as easy and effortless and painless as possible for us. And who cares how big our game gets or how slow it runs, as long as we can ship it. So that's the complexity factor, right? So ideally, you don't want to be selfish. You don't want to make the game as uncomplex as possible, right? But you do want to have a little bit of complexity reduction, because making things too complex has risks attached. So as you can imagine, um, if the developer doesn't want to make the game anymore, it's never going to be published, and then the player base never gets the game, right? So think of your favorite game, like a AAA game or whatever you like, and think of an upcoming sequel, right? And now imagine that the publisher or the studio makes an announcement this week saying, oh, by the way, that game you guys were expecting for 2.5 years, well, we're going to cancel it. It's just too complicated to make. We're not feeling it anymore, and you're never going to see it. Right? This happened to us with Half-Life 2 Episode 3, and then that became Half-Life 3, and that never happened. Now, apparently, I don't want to talk about this, but there's rumors going around that maybe Half-Life 3 might be coming out. But I don't want to say anything about that. I shouldn't even have used it as an example. So I apologize for that. But yeah, in the end, you do want to reduce complexity a little bit, because if the game is never shipped, then all of your space and your time savings are wasted because the game's not done. It's never been published, right? Okay. So if you want to have savings on all three, you'd end up with something like this. Not optimal for any of them, right? But you make savings on all of them. But realistically, you would never save only on one. You'd save on two, right? So let's say you want to be player-centric rather than developer-centric. You'd end up having something like that. You have some complexity savings, but really not that much. The majority of it is here between space and time, right? Or you could do space and complexity and not save on time. You could do time and complexity and not save on space. Same thing, different optimization, right? So that's that. And now that you understand, or at least I hope you understand, let's get back to Godot engine. So right. So I was talking about using groups and setting groups at runtime so that I don't need to use 9 different scenes, right? One for each player class and their status as either player or enemy/ally NPC. And so this is a balancing act, right? Like I mentioned, it's between complexity and space. You're saving between space and complexity because every single scene I create takes up space on my player's machine. But I can save space and use groups, but that increases the complexity. So you see there's this trade-off. Right, enough on that. So this is the defender ship. And I want to make another defender ship. So I want to make Let's close all of these. And then go to the file system, scenes, entities here. So we'll call this, rename it, Defendership, or we'll say Defender dash, or we'll say Player dash Defender. I think that's a better naming system. You say Player dash Defender, and here we say rename. This becomes Enemy dash Pirate, and this becomes Player dash Miner. Okay, so if I open up the Player Miner, I can save the scene. Now we get a thumbnail. We can go to Player, save the scene, go to the Pirate, and save the scene. Okay. So the next thing we need to do to get this thing working, I want to make sure that each of our player scenes uses the same player script. And so I need to scrub all of the unnecessary things out and put them into separate modules, right? So in player behavior at the top, let's just check everything here is actually required. So we've got the speedometer, the reading, controls int label, pause menu is pause, display speed, the speeds, accelerations, rotations. Yes, okay. Okay, that's fine. Okay, that's fine. That's fine. This is just the pause menu logic, that's okay. Input, this has to do with rotation, that's okay. Physics process. Accelerate, decelerate, brakes, recenter, rise and fall, strafing left and right, handling all the rotations, still handling rotations, and then displaying the speed, and then actually moving the player. Perfect. So that's everything we need. Excellent. So if I go to the miner, we'll see the mining vessel has this mining player behavior, which is not what we want. We don't want a separate player behavior just for the mining vessel. So the workaround, or not the workaround, but the way to fix this is to check in the mining vessel script. So if I go to the script here, mining player behavior, what is there in this script that isn't in the general player behavior script? And how can we extract it to a separate module so that we don't need this script at all, ever, right? Barrel's been started, barrel's been stopped. So if I click on the mining vessel, We can go to the signals. You can see battle spin started and stopped is not connected to anything. And now I'm wondering, did we ever need it? So if I go to battle behavior, what is this? Body entered, body exited, battle spin started, battle spin stopped is not being used. So if I go to mining player behavior again, emitting the signal, battle spin started. But battle spin started is not connected to anything. The shoot function only rotates the battle. Are you seeing this? Right? So all of this logic can go into battle behavior. We can just do that. We can say, okay, oh yeah, it is on battle spin started, on battle spin stopped. Why are they not connected? Anyway, does it need an exploded? I don't think it does. Oh, when was this? I see there's a comment saying my camera went off. Could you just tell me in the comments when was this? How long has my camera been off for? Let me fix that. Fix that quickly. I might need to. Excellent. It's back. Okay. Okay. Thanks. Thanks for letting me know. Okay. We don't need these anymore. We don't need these anymore. But again, let's keep this file as is, right? And just focus on making this one do all the lifting, all the heavy work, right? So the battle area, where's this thing? Here. So everything we need is here under grinder barrel, right? We want the whole barrel to rotate. We want to manage the grinder barrel and all its collisions and everything from this script. And all of these things are children of grinder barrel. So we don't need to do any kind of complicated signal connections going up in the hierarchy towards like parents or grandparents or whatever. It's all just down towards children and grandchildren on this the hierarchy, the scene tree. Perfect. So if I go back here, what is the barrel? It's the grinder barrel. That's this thing. So that's self, right? So if I go to barrel, I can say transform dot rotate. just go to DeepSeek and ask, how do I make the current node rotate? Is there a self keyword in GD script, or is there a better way to do this? Rotation degrees plus dot y plus equals 90. Self rotation degrees is this. Using a transform, rotate y degrees to radians 90. Over time in process, rotate y, rotation speed times delta. Rotation dot y plus equals rotation amount. Rotate y, rotation amount. Okay, so let's do that. I just used the whole rotation factor, didn't I? Or was it your? I think it was your. Let's go to shoot. Pitch rotation factor. And that was this one. Okay, so let's go to battle behavior. We'll create an export variable. Export variable battle rotation factor is of type float and is assigned a value 0.05. Or we could just say degrees to radians and say we wanted to rotate by 5 degrees, 15 degrees, 15 degrees a second. Okay. Notice how the columns are now all out. So let's do that. Fix this. So that there, and there. And then you go there. You go there. Perfect. Okay. Export variable barrel rotation factor. That's where we were. And now we want a variable called spinning. Oh, yeah, it is. It's already there. So now let's go here. We'll say if the player presses shoot, we'll just copy. We're not going to damage. We're going to do non-destruction, non-destructive workflow with this particular script because we're not going to use it, but we do need to refer to it until we are done. So let's just be careful. Okay, so just do this here. And then we need to define a shoot function. So I can go here, something like this, and just say shoot. Define a function called shoot. Takes in no parameters, returns nothing. Then I can check this here. If input action is pressed, we set spinning to true, and then we call this rotation function in the shoot function, so this one. So we could have said rotate X instead of saying rotate by this vector 3. So let's do that. We'll say rotate underscore X. So this will automatically rotate along the X axis with an amount per second, right? Set spinning to true, rotate by this much, else spinning is false. Then check if it's spinning and there's a body in contact, more than one. So if we have more than one body in contact with the barrel, then we do continuous damage. Okay? And then we don't need these anymore. Okay. Apply continuous damage. Process on body entered and exited. That seems fine. Then I can go to the mining scene, and here I can say detach this and attach this. So let's go to scripts, behaviors, well, player behavior, attach it. Then I can go to firing range, switch the player ship to be the mining ship instead. So like this. And make sure everything works. Okay, so there we can see the drill actually turns, which is awesome. And we're moving backwards. Okay, that's not a difficult fix. We just go to the miner, select the mining vessel, and just rotate it 180 degrees on the transform. And I can go to the firing range, save the scene. Why is the bounding box so huge for the player? It's the camera, main body. The spotlights. Okay, the spotlights are what's taking up so much space. Okay, that's fine. Okay. Barrel area. Copy node path. Grinder arm, grinder barrel. I think it's just this area grinder barrel. Now I can go back to the firing range and then add a miner back. Play defender. Doing one of the rotations. And then we can go into player behavior. We'll see play behavior, physics process, UI up should be plus equals acceleration, UI down minus. Okay, so let's do that. We'll go to the 3D scene and check. Forward is forward, but now it shows negative speed, and backwards is backwards, but it shows positive speed. Fine. Check here. Display speed. Positive display speed. Okay. And then just go back and make sure that works. Forward is forward. Backwards is backwards. Stop is stop. And then we do one last test. We delete this one. We add this one. They are opposites. Going backwards. See, this is why I wanted to make the import process standardized because of this kind of nonsense. Um, now what? What if I just did this? No, because that only turns the mesh, not the camera. Um, I'll have to fix that or figure something out. As for the live stream, we have run out of time. It's now beyond an hour, so I'm going to close things here. Thank you to Cubes for your continued support. He's our junior DevVenturer, and you guys can join him as DevVenturers by visiting coffee.com/mtkdev. The link is here at the bottom right of the screen. And then also don't forget you can join the Discord community. The link is in the description of each live stream. It's the same link. It's open all the time to as many people. So you can just join anytime you want. Yeah, that's it. Thank you so much for your time.